9-2, multiplying polynomials by monomials. To find the product of a monomial and a binomial, you can use the distributive property, distributing or multiplying the monomial by every term in the binomial. You can also use the distributive property to find the product of a monomial and a longer polynomial. When polynomials are multiplied, the product is also a polynomial. Therefore, the set of polynomials is closed under multiplication, similar to the system of integers, which is also closed under multiplication. So we are going to review even with exponents here, because remember, when you multiply like bases, you add the exponents. So I need to distribute, and I get negative 8x to the third. Negative 2 times 3 is a negative 6, x squared. And negative 2 times negative 5 is a positive 10. That's an x. And so our answer would be negative 8x cubed minus 6x squared plus 10x. Now, if I could simplify that further, I would, but otherwise there's no like terms, so that would be my answer. Next one, distribute negative 3x to all three terms. Negative 3 times 5 is negative 15. X times x to the fifth is x to the sixth. Negative 3x times negative 3x squared is a positive 9x to the third. And then negative 3 times 7 is negative 21x. Example 2, simplify these. So we have to get rid of our parentheses, so I'm going to distribute. 3n times 6n cubed is 18n to the fourth. 3n times negative 4n is a negative 12n. Here I have negative 2 times 9n to the fourth will give us a negative 18n to the fourth. And negative 2 times negative 11 is a positive 22. You'll notice that I wrote my answers vertically so I can add like terms. The n, 18n to the fourth cancel each other off, and I'm left with negative 12n plus 22. Next, distribute here. I get 10n to the fifth plus 12n squared. And then distribute here, minus 15n to the fifth. Negative 5 times 3 is negative 15. N to the third. Since I don't have any other n squares, so if I add straight down, I have negative 5n to the fifth plus 12n squared minus 15n cubed. Now I'm going to put this in standard form, which would make that negative 5n to the fifth minus 15n cubed plus 12n squared. Example 3, write and evaluate a polynomial expression. Here we have a word problem. It says the world's largest basket is a building. Each face of the building is in the shape of a trapezoid, with the largest face having a height of h and two base lengths of h plus 90 and 2h plus 84. Write and simplify an expression to represent the area of one side of the building. Now, to find the area of a trapezoid would be 1/2 the height times base subscript 1 plus base subscript 2. So if I substitute the numbers in, I have 1/2. The height is h, and the base is h plus 90 plus 2h plus 84. So now if I simplify that, I now have 1/2 h times 3h plus 174. And if I distribute that, I would have 1/2 h times 3h would give us 3/2 h squared. And 174 divided by 2 would give us 87, so plus 87h. Next, Mike is designing a shed. He wants the building to be in the shape of a rectangular solid with the same width and length and a height that is 2 feet shorter than the width. Write and solve an equation to represent the volume V of the shed in terms of the width W. So the volume of a rectangular solid is going to be length times width times the height. They said the length is the same as the width and that the height is going to be the 2 feet shorter than the width. So the width minus 2. So if I substitute those values in for the volume, I have the volume, the length is our width, times our width, times our width minus 2. So the volume is going to be W squared times W minus 2. And to simplify that, the volume is going to be W cubed minus 2W squared. Next, sum up each equation. Here we have negative 16p equals negative 2 times p plus 3 equals plus 3 times 6p minus 30. What we need to do is get rid of our parentheses. So distribute negative 2, so that gives me negative 2p minus 6 plus 18p minus 90. This is going to equal negative 16p. Now I need to get everything to one side. So then we can eventually solve for p. I'm going to get the p's to one side. So I'm going to combine like terms. So I have negative 16p here equaling negative 2p plus 18p is 16p minus 96. To get the p's to one side, I'm going to subtract 16p on both sides. And I'm left with negative 32p equaling a negative 96. I'm going to divide by negative 32. I now have 96, negative 96, divided by negative 32, and p would equal 3. Next example, going to distribute here. That gives me a negative 8q squared plus 18q equaling negative 8q squared plus 15q plus 12q plus 18. Then I combine like terms on each side. I'm going to get the q's to one side. So I'm going to add 8q squared. And then this becomes 27q. So I'm going to subtract 27q on both sides. And now I'm left with a negative 27 plus 18 gives us a negative 9q equaling, on this side I have 18 divided by negative 9. Q would equal a negative 2. Moving on to our next example, distribute negative 3. So right now I got 20p equaling 3p minus 15 plus 10p minus 20. Combine like terms, so I got 20p equaling 13p minus 35. Get the p's to one side by subtracting 13p. And we have 7p equaling a negative 35. Divide by 7, p would equal a negative 5. Coming from example 4, distribute. So we have 2p equaling 12p minus 30. I'm going to subtract 12p, and I get negative 10p equaling a negative 30. Divide by negative 10, p would equal 3. And our last question, distribute. That gives us 6q squared minus 15q equaling negative 6q squared plus 30 minus 50q minus 30. Combine like terms on each side. This stays the same as 6q squared minus 15q equaling negative 6q squared. I now have the 30s cancel out, minus 50q. Going to add 6q to both sides, 6q squared. And then I'm going to add 50q. Now have 12q squared plus 35q equals 0. Now here I just think, what does q possibly could give me to make that equal to 0? For everything that equals 0, q would have to be 0 because 12 times 0 squared plus 35 times 0 would be 0. I would have an answer of q equaling 0. So that is our lesson on multiplying polynomials by a monomial.